Systems in two equations in two unknowns. A linear equation in two unknowns is an equation that can be written of the form ax plus by equals c, with a, b, and c being real numbers. A is the coefficient of x, b is the coefficient of y. A solution to a linear equation is a pair xy that satisfies the equation. Some examples. The equation 3x minus y equals 10 has a solution. It has, in fact, infinitely many solutions. One particular solution is the point 4, 2. Because we plug in 4 for x and 2 for y, then we get 3 times 4 minus 2 equals 10. So the equation gives us a true sentence. The pair 2, 2 isn't a solution because we plug in 2 for x and 2 for y. 3 times 2 is 6, minus 2 is 4, and 4 is not equal to 10. Any linear equation has infinitely many solutions. Any pair of points, x and y, that satisfy the equation are good enough as a solution. So some examples are 0, negative 10, 2, negative 4, 6, 8, etc. When we find solutions to two linear equations, we're interested in pairs of points that satisfy both linear equations at the same time. There are a couple of different options here. We can have one solution, we can have infinitely many solutions, or there can be no solutions at all. So here's an example. Find all solutions x and y that satisfy x plus y equals 3, x minus y equals 1. The first method is the graphical method. Here we draw a graph of x plus y equals 3 and a graph of x minus y equals 1 and see where the two intersect. We notice that they seem to intersect where x equals 2 and y equals 1. And indeed, if we plug in x equals 2, y equals 1, we get x plus y is equal to 3 and x minus y equals 1. Another method is the algebraic method. In this case, we have coefficients that match in front of the y's, where the only difference is the sign. So we can go ahead and we can add these two equations. So x plus x gives us 2x, y minus y equals 0, and 3 plus 1 is 4. So we end up with 2x is equal to 4, or x is equal to 2. If we take our x value and plug it in to one of the equations, then we can find that y is equal to 1. So our solution again is 2, 1. One issue that we face with the graphical method is that it's difficult to actually find the intersection point if the two equations don't have a clear integer solution. So consider the system of equations 3x plus 5y equals 0 and 2x plus 7y equals 1. We see them graphed here. And we can see that the solution is kind of around x equals 0, maybe a little bit smaller than that, but we can't say for sure what it is. And in fact, very much hamstrung by how good our graph is. The actual solution is negative 5 over 11, 3 over 11. But again, it seems impossible to have guessed that from this diagram. So we try and stay away from the graphical method when at all possible. We mentioned that systems of linear equations can have a unique solution, no solutions, or infinitely many solutions. An inconsistent system of linear equations is a system of equations with no solutions. Essentially, what we have is two lines that are parallel. These equations have the same slope, but different y-intercepts. So for example, we want to find the pair of values x, y that satisfy 2x minus 6y equals 10 and negative 2x plus 6y equals 8. We can again see that the coefficient in front of the x is the same for both equations, and so we can simply go ahead and add. If we do that, we get 0x plus 0y equals 18, and so 0 is equal to 18, which is clearly not true. Because we've got a statement here that's clearly untrue, we have no solutions to this system of equations. In fact, if we go ahead and graph this out, you can see that these two lines, the pink and the blue, are parallel. A redundant system of equations is a system of equations that has infinitely many solutions. Again, when we look at these two equations, they have the same slope. The difference is that they also have the same y-intercept. So really, if you have a redundant system of equations, one of the equations is a multiple of the other equations. So here's an example. Find a pair that satisfy x plus y equals 2 and 2x plus 2y equals 4. And if we go ahead and we multiply the first equation by -2, we get -2x minus 2y equals 4, 2x plus 2y equals 4, and we add to get 0 equals 0. So our solution, given any x value that we'll call t, 2 minus t is a y value that will satisfy both equations. And of course, both equations, x plus y equals 2 and 2x plus 2y equals -4, are the same line. So there are multiple possibilities when we're dealing with systems of two linear equations with two unknowns. A single unique solution, which happens when the lines corresponding to the two equations are distinct and not parallel, so they must intersect at a single point. We have a situation where we could have no solution. This happens when the two lines are parallel. A system like this is called inconsistent. We could have infinitely many solutions. This happens when the two equations represent the same straight line. We say that such a system is redundant or dependent. In this case, we can represent the solution by choosing one variable arbitrarily and solving for the other. In cases 1 and 3, we say the system of equations is consistent because it has at least one solution.